there. In the following video I will answer the AQA Unit 2 Higher Maths GCSE November 2010 past paper. Okay, let's start straight away with question 1. Use approximations to estimate the value of the following. Do remember approximations and estimate basically means find a sensible answer to the following. Don't work it out exactly, find a sensible answer. Easiest way to do this is round every number you see in the calculation to one significant figure. So, looking at the top number here, if you look at this number from left to right, the first number is in the tens column, so the nearest 10 to 98.7 is 100. So on top this would be approximately root 100, and the bottom, the first non-zero number, is a 1 in the units column. The nearest unit to that is 2. So this is like the square root of 100 over 2. The square root of 100 is 10 divided by 2, and you get the answer 5. It's approximately 5. Nice easy start to the paper. Question 2. You are given that the following is true. Now I would always advise you to just write the associated division facts with this to help you with later parts, even before you look. If I know that 23.5 times 64 is 1504, I also know that 1504 divided by 23.5 must give me 64, and I also know that 1504 divided by 64 must give me 23.5. Always useful to have my multiplication and division facts up at the top. Okay, let's look at 2a. Work out the following. 23.5 times 6.4. It's very like what you're given above, apart from the second number is 10 times smaller, has been divided by 10. So we just divide our 1504 by 10 and we get 150.4. Work out the following. 1504 divided by this. Well, our division fact from above was that 1504 divided by 64 was equal to 23.5. But on the bottom here, we're dividing by an extra factor of 10. We're dividing by something which is 10 times bigger, which will make our answer 10 times smaller, so the answer must be 2.35. And lastly, 23.5 times 65. Well, we know from above that 23.5 times 64 is equal to 1504. So 23.5 times 65 must be one extra lot of 23.5 added onto 1504. So it must be 1504 plus an extra 23.5, and that's easy to calculate. That must be 1527.5. And the second question is done fairly easily. Okay, question 3. The value of this expression is negative 10. Work out one possible pair of values for x and y. So you've got that this number x multiplied by y plus 2 all divided by 9 is equal to negative 10. A little bit confusing. Why don't I multiply both sides by 9 just to make it a little bit more easy to work with? So I would get x, y plus 2 must equal minus 90. Now we've got two numbers here and here that multiply to minus 90. Well, what could those numbers be? Well, x could be 10, let's say, and y plus 2 could be minus 9, because 10 times minus 9 is minus 90. So that would give me a pair of solutions of x is 10 and y would be minus 9 minus another 2, subtracting 2 off both sides, so y would be minus 11. A pair of x and y that make this work is therefore x is 10, y is minus 11 or negative 11. Obviously there are many correct solutions to this, but if you get yourself to this point and pick your x and y, anything that times is up to negative 90, you could get several different answers. But here is an example of one. Okay, question 10. Liz has a £20 voucher on an online music shop. She buys 10 songs costing 80p. What percentage of her voucher has Liz spent? Well, let's work out how much Liz has spent. 10 songs. How much do they cost? Well, they cost 10 multiplied by 80p, which is £8. Okay, so that's all she spent out of her £20 voucher. So percentage spent must equal 8 over her total of 100, and then that fraction, and you multiply it by 100 to get the percent. Now, how do we work out this as a percent? Well, we could 8 divided by 20 is the same as 4 divided by 10, simplifying that fraction, which is 0.4 times 100, and 0.4 times 100 is 40%. So she has spent 40% of her voucher money. Again, nice straightforward question. Moving on to question 5. We've seen lots of these number machines. You put input numbers in, you get output numbers out by doing the rules that they tell you that the machine does in the correct order. Calculate the output when you put in -1. So you start with -1. You add 7 and you would get 6. You divide by 2 and you would get 3. So the output is 3. Nice, simple. The output when the input is -1 is 3. Here is a different, key thing here, different number machine. You put some numbers in, you multiply by 5, then you subtract 6 and you get an output. The output is equal to the input. What must the input be? So you want the output to equal the input. Now again, you could go ahead by trying various numbers, like for example if you put 10 in, you do 10 times 5 is 50, 50 take away 6 is 44. Are they the same? No, so 10's no good. So you could try numerous different numbers. I would always advise to jump straight to algebra here. Put in a number using a letter, and why don't we call that number n? Multiply by 5, a mathematician writes n multiplied by 5 as 5n. Then subtract 6, so you get 5n subtract 6. And your output is 5n subtract 6. You want the input to equal the output, so you want that number you put in n to equal 5n subtract 6. You've got a linear equation here, and you can solve in the normal ways to find n, what this input must be. I would subtract n off both sides, so you get 0 is equal to 4n subtract 6. Add 6 to both sides, you get 6 was equal to 4n. And finally divide both sides by 4, you would get n is 6 divided by 4, which is 1.5. And you get 1.5 as your input. Don't just leave it there, do check it works. If you do 1.5 times 7, you get 7.5, and 7.5 take away 6 is 1.5. Input equals output. I got it right. Okay, moving on. Question 6. We've got a graph here showing 2 training runs by Pat and Vicky. Up this side is the distance in kilometers. So each big square here is a kilometer, and each of the big squares is divided into 5 smaller squares. So a small square must be equal to 200 meters then, a small square. Always worth doing this with questions just to get a feel for things. And across we've got time. So each big square is worth 5 minutes, so each little square is 1 minute. Before we see the questions, let's just try and tell the story ourselves. Let's talk about Pat here. Pat starts off and travels at a constant speed up till 5 kilometers, and it takes it looks like it takes somewhere in the region of 30 minutes. Has a stop and starts off again, and it looks like Pat goes faster because the gradient of the line is steeper here than she went before. Vicky starts off quicker than Pat. Gets to 6 kilometers, has a pause, and then goes off again. Okay, let's have a look at the questions. After how many minutes does Pat overtake Vicky? So Pat is this one here. Pat has always travelled less distance than Vicky because you're underneath, her line is underneath Vicky's line until this point here where she suddenly overtakes her, and that looks to me like it's about 50 minutes. It's approximately 50 minutes. It is important in the exam actually to just draw a line, interpolate here just to show how you read off it was 50 minutes. How far ahead is Vicky when Pat starts again after her rest? So where does Pat start again after rest? This is Pat's line here. This is her rest. She starts again at this point, and the question is, how far ahead is Vicky? Well, Vicky is at this point here, so we'll draw some lines across to see the distance here and the distance here. You can see that Pat is approximately 5 kilometers. She's travelled 5 kilometers, and Vicky has travelled about 6.5, or slightly more than 6.5 actually. If each one's 200, she's travelled 6,600 meters. So the difference is 1,600 meters, or 1.6 kilometers. So in here, I would say 1.6 kilometers. Okay, moving on, next question. Question 7. Such a straightforward question here. Divide or share out £600 into the following ratio. Okay, how many parts do we want to share it into in total? So step 1, work out how many parts needed. 9, add 6, add 5, and that is 20 parts. So in total there are 20 parts. Let's work out the value of one part. One part must be 600 divided by 20, which you can say is equal to £30. And now, to work out how many each has, you multiply their number of parts by how much one part is worth. So you do 9 times 30 for that first bit, you do 6 times 30 for the second bit, and you do 5 times 30 for the third of 5 parts. So 9 times 30 is £270, 6 times 30 is £180, and 5 times 30 is £150. A nice check at the end, just to check you haven't made a silly mistake, is to add up your 270, your 180 and 150, and they should add up to the total, which is 600. And in this case, you would get 13 and 7, it's 20, carry that, and you would get yourself 600. So you know, it seems that you've done the correct work in there. Each of these amounts add up to the 600 you divided. Okay, moving on to question 8. So Martha's selling jars of jam at a farmer's market. She has 80 jars and she wants to sell them at £3 each. She ends up selling 50 at the correct price and then reduces her price by 40%. She sells the remaining jars at the reduced price. It costs her £95 to make jars of jam. Her target of profit is £100. Does she meet her target? Obviously here, do remember at the end to state, based on your workings, whether she does or doesn't meet her target, because there will be a mark of the 5 for that statement. Okay, now in real life, in business, your profit is your income or your sales, how many sales you've made, subtract your cost to make the items you're selling. Now we know she wants to make £100 profit. We don't know her sales, but we know her costs are £95. So adding 95 to both sides, her sales must be 195. Just adding 95 to both sides. So to meet a target, she needs sales of £195. So £195 equals sales in order to meet target. Okay, well let's work out her sales. She sells 50 jars, and she sells them at £3. So 50 times £3 is 150. So that's how much at full price. Now let's work out reduced price. She reduces the rest, the reduced price. They were originally £3, so we could work out what a 40% reduction is. Two ways to do this. Either do 3 multiplied by 0.60, which is the decimal multiplier that causes a 40% reduction, and you would get £1.80. Or you could simply work out 10% of £3, which is 30p. So therefore, 40% of £3 must be 4 times 30p, which is £1.20, and take it off from £3, you'll get £1.80. So the reduced price is £1.80, so the remaining 30 jars are sold at 30 multiplied by £1.80. How do I do this? Well, I could do 30 times 1 is 30, and 30 times 0.8 is equal to £24. So this adds up to £54. Okay then, so we can work out that our total sales, therefore, total sales is 150 plus 54, and that adds up to £204. So state at the end, therefore yes meets target. Quite straightforward question for 5 marks. Question 9. X divided by 5 is equal to -6. So to solve, multiply both sides by 5 and you would get x is equal to -30. Nice straightforward marks that x is -30. Double check it works. -30 divided by 5 is -6. Factorise fully 4t subtract 20. The highest common factor of 4t and 20 is just 4. Divide out by 4. 4t divided by 4 is t. 20 divided by 4 is 5. So t subtract 5. 4t minus 5. Take a second to times it out and check it works, but it does. Expand and simplify the following. 3 times 2m is 6m. 3 times -4 is -12. Positive 5 times m is positive 5m, and positive 5 times 2 is positive 10. Now tidy up. 6m plus 5m is 11m. Negative or minus 12 plus 10 is minus 2. Again, very straightforward marks there. 9 part D, simplify fully the following. We're doing a multiplication here, so we can times in any order. In particular, let's start off by timesing the numbers. 4 times 2 is 8. Actually, I'll rewrite this for us just to make it clear what we're actually doing. I'm just reordering the timesing. So I'm going to do the 4 times the 2 at the front, and I've dealt with those two. I'm going to do the g times the g cubed next, and I've dealt with them two. And then I'm going to do the k squared times the k cubed, and then I've dealt with them too. These are exactly the same, but I've just reordered the multiplication. 4 times 2 is 8. G times g cubed, well that's like g to the power of 1 times g to the power of 3, so add the powers and you get g to the power of 4. K squared times k cubed is k to the 2 plus 3, which is k to the 5. And factorise fully the following. Well, what is the highest common factor of 10q squared and 15qr? Well, 5 goes into both and q goes into both. Divide it out. 10q squared divided by 5q is 2q. 15qr divided by 5q is 3r, and it's a subtraction. Times it out again to check you've done the right thing. And quite straightforward marks there. Okay, question 10. Here is an addition pyramid. Each number is the sum of the two below it. So 6 is the same as 2 plus 4, and 9 is the same as 4 plus 5, and 15 is equal to 6 plus 9. Here is an algebraic addition pyramid. Work out the value of k. Okay, well just follow your nose. Fill in that box and that box, given that you know it's an addition pyramid, and then add those two together to get you what the one above is. So let's do some working. Add this, add this. first of all, just times this out. That would be x squared minus 4x, and this here is 6x minus x squared. No need to times out, and this is 4x. So on the one hand, x squared minus 4x plus 4x is equal to x squared, because they cancel. So up here must go x squared. And over here, adding these two to get this one, 4x plus 6x minus x squared is 10x minus x squared. So up here must go 10x minus x squared. So I might call that row 1. And using the row 2 facts, adding these two must give you that one. So x squared plus 10x minus x squared minus x squared is nothing, gives you 10x. And you know that it must equal to the kx above it. So if 10x is equal to kx, k has to be 10. K is forced to be 10. Okay, moving on to the next question. Question 11. 27 to the 2/3. Just a routine with these type of questions. Work out 27 to the unit fraction of a third and then raise that all to the power of 2. Because a third, we've got a power of the power here, and if you multiply these powers, you get the 2/3 you're looking for. But it's easier to work it out like this. Now 27 to the third means the cube root of 27, and you want to square that answer. Well, what is the cube root of 27? What number multiplies by itself 3 times to get 27? Well, the answer is 3. And then you square that, and you get 9 when you do that. So the answer for question 11 is 9. Question 12. Dan has lost weight. He now weighs 108 kilograms. He has lost 10% of his weight since March. How much did he weigh in March? So, he was 100% weight. He lost 10%. So he now weighs 90% of his March weight. And that's 108 pounds. So 90% is worth or equivalent to 108 kilograms. So I want to work out his March weight. I want to work out how much 100% was. Well, we can do that by working out 10% by dividing by 9. So divide this by 9 and you get 12 kilograms. So 10% is 12 kilograms. So 100%, which is his March weight, is that times by 10. So it's 120 kilograms. So his March weight is 120 kilograms. Let's just think, does it work? If he was 120 and he lost 10% of this weight, well, he would lose 10% of 120, which is 12. 120, take away that 12, gives me the 108, which I now know he weighs. So I definitely know I got the right answer. Okay, question 13. The rule for finding the next term in a sequence is the following. Subtract A and multiply by 4. It tells you the second term is 12, the third term is 52. It doesn't tell you the first or the fourth terms. It asks you to work out the first term. Okay, so let's have a go at this. Well, we know, we don't know what the first term is, but we know that the second term is equal to 12. To get the third term, we would subtract A and multiply by 4, whatever the previous term was. So we would do 12, subtract A, and we would times all of that by 4. Timesing this out, you get 48 minus 4A. But we know the value of the third term. We know it's equal to 52. So now we can find A. We can solve for this A that we're subtracting each time. If you subtract 48 from both sides, you get negative 4A is equal to 4, and then divide both sides by the negative 4, we would get A is equal to negative 1. So this subtracting A is actually subtracting negative 1. Therefore, the first term, which is what we're asked to work out, We've got this at the first term, let's call it x. We don't know what it is, x. We've got x, we subtract minus 1, we subtract minus 1, then we times by 4, and we get our answer of 12. Well, x subtract minus 1 is like x plus 1, so this is like 4x plus 1 is 12. Could times out the brackets here to get 4x plus 4 is 12. Subtract 4 from both sides, 4x is 8, so x, our first number, must be 2. So I'm thinking that the first number here, x, must equal 2. Let's just check it does. If I had 2 here and I subtracted minus 1, it would be like adding 1. So 2 plus 1 would be 3. 3 times 4 would give me the 12. Okay, question 14. Show clearly that x plus 5 multiplied by x minus 5 is identical to x squared subtract 25. You'll remember this is the difference of two squares. But in this particular case, I'm not allowed to use the knowledge of difference of two squares. They're asking me to actually show that this works. So start with the left-hand side of the equation. The x plus 5 multiplied by the x subtract 5. X times x is x squared. X times negative 5 is minus 5x. Positive 5 times x is plus 5x. And positive 5 times minus 5 is minus 25. These cancel, and I get x squared minus 25, which is equal to my right-hand side. 14 part B, simplify the following. This is an algebraic fraction. When I'm trying to simplify these algebraic fractions, the best and first move I should use is to factorize the top and bottom of those fractions. Now, if you think about it, I know how the bottom factorizes given 14a, because I know this factorizes to x plus 5, x minus 5. So the very first thing I could write straight away is the denominator of that fraction factorize. Now all I'm left to do is actually factorize the top. Now, what does the top factorize to? Let's just try and factorize 3x squared minus 19x plus 20. There were a couple of ways I've shown you how to factorize it, sort of a clever way that you get through practice and a long algorithmic way that you can always work through and get the right answer. I'll show you the quick way. I'll do the quick way down here. 3 is a prime number, so 3x squared had to come about by multiplying 3x and x. It had to. What can I multiply to give me 20 that when I times it out I get negative 19? Well, I'm thinking in my head minus 4 and minus 5 because they times to 20. And could I get that to work at all? Well, if I put minus 5 here and minus 4 here, then I know that these two times to the 20. I know that and that times is to that. Minus 4 times x is minus 4x, and 3x times minus 5 is minus 15x. Minus 4x minus 15x gives me the term I'm looking for here. So that actually works. Another way of doing it, I said what you could do, step 1, you could take that term and multiply it by the third term. So you could do 3 times 20 is equal to 60. Step 2, you ask yourself the question, what multiplies to give 60 and adds up to give minus 19? And with a bit of thought, you'll think to yourself there that negative 15 and negative 4 do the trick for us there. So you've got a 3x squared here, so put in this bracket's a 3x minus 15, this bracket's a 3x minus 4, and where you can simplify, make sure you can. There's nothing goes into 3x and 4 other than 1, but 3 goes into both these, and so simplify and cancel it out, get x subtract 5, 3x subtract 4. There's your factorized version again. Okay, let me just rub this out because we've got our factorized version. Now that you've factorized, write the top and bottom in their factors. So this top actually factorizes to 3x minus 4, x minus 5, and all of that divided by the bottom, which is x plus 5, x minus 5. X minus 5 is multiplying on top and on bottom, so you can cancel and you're just left with 3x minus 4 over x plus 5. Very good. Okay, question 15. Make y the subject of this formula. So you want y is equal to something involving all the other expressions but not including y. So you want something like this. Y is trapped within the brackets here. Free the y from its brackets. So 3y minus p must be h times 2 is 2h. H times y is plus hy. Gather all the y's together on, say, the left-hand side. So why don't we subtract hy from both sides? You would get 3y, subtract p, subtract hy is equal to 2h. Remove this here because it doesn't have a y in it, so add p to both sides. So you've just got things with y's in it. 3y minus hy is equal to p plus 2h now. You've got a y as a factor of 3y and a y as a factor of hy. So factorise the y out, you would get 3 minus h in brackets is equal to p plus 2h. And lastly, divide by 3, subtract h, and you would get y is equal to p plus 2h divided by 3 minus h. Y equals p plus 2h divided by 3, subtract h. Y, the subject of the formula. Question 16. On the grid, A is the point 0, 1. So A is the point 0, 1. The midpoint M of AB is 2, 7. The gradient of AB is 3. Okay, work out the equation of the line through C parallel to AB. So you want a line parallel to AB but through C. Right, let's have a go at this. We know that the gradient of this line is 3 here, so we want the gradient for this to be parallel to this. This would also have a gradient of 3. Okay, so this here must have a gradient of 3 for it to be parallel. So the key point really is just to work out that coordinate now. Let's just see if we can work out, if that's the midpoint of this line, we've gone across 2 and we've gone up from 1 to 7, which is 6. So to get to this point here, we must have to go across another 2 from 2, so we'd be over at the point 4, and we must go up another 6 from 7, so we'd be at 13 high. So this, the coordinate here, this must be 13 high, it's got coordinate 0, 13. We know that y equals mx plus c, the equation of a straight line. This line, for it to be parallel to this, must have a gradient of 3, so must have an m of 3. And we know that this coordinate here, where it crosses the y-axis, is 0, 13, so c must be 13. Substituting in, our equation of the line is y equals 3x plus 13. Okay, nearly there. Question 17. Write the following in the form a root 3, where a is an integer. Integer means whole number. Just follow your nose here. I would suggest you just follow your nose. There are different ways of doing it. I'll show you one way over here. This whole expression over here, the problem I don't like with it, a mathematician does not like a surd on the denominator of a fraction. So the 6 over root 3, I would find an equivalent fraction where the root 3 is not on bottom by multiplying top and bottom by root 3, and I still have my plus the square root of 75. Okay, on the bottom, root 3 times root 3 is 3. 6 times root 3 is 6 root 3, and you've still got your plus root 75. 6 root 3 divided by 3, or 6 divided by 3 is 2, so you've got 2 root 3 here, plus square root of 75. Okay, we're not there yet because we want it in the form a root 3. This is looking good, this isn't. Could I simplify the square root of 75? What's the biggest square number I can think of that divides into 75? Well, 25 does. So I could write 75 as 25 times 3 and break that up further. That would be the square root of 25 times the square root of 3. Well, the square root of 25 is 5, so this is 5 root 3's. So I've got 2 root 3's plus 5 root 3's, and that simplifies out to 7 root 3's. So the answer would be 7 root 3's, where a is equal to 7. Nice and straightforward there. Okay, question 18. Two integers, again integers, whole numbers have a difference of 3. The difference between the squares of the integers is 3 times the sum of the integers. So for example, if you took the numbers 13 and 10, if you subtract them, their difference is 3. But if you square them first and then subtract them, you get the answer of 69. However, that is also happens to be the same as if you added the numbers 13 and 10, which is 23, and then multiplied by 3, you get 69. You have to show this is true algebraically. So pick two numbers with a difference of 3. Why don't we pick the number n and the number n minus 3? They certainly have a difference of 3. If you take them away from each other, you get 3. So there are two numbers. Okay, let's do the first bit. Let's square them and take them away from each other. So let's do n, that number squared, and subtract n minus 3 squared. Well, the number n squared is just n squared, and we want to subtract all of this squared. Well, that means n minus 3 times n minus 3. I'm going to put big brackets there to just say I'm going to subtract this whole answer afterwards. So let's do it. N squared subtract. N times n is n squared. N times negative 3 is minus 3n. But minus 3n times n is minus 3n. Minus 3 times minus 3 is plus 9. Tidying that up, I get n squared subtract n squared minus 6n plus 9. Okay, well let's now do the subtraction. N squared minus n squared is nothing, and then we'll have a 0 minus 6n is plus 6n, and 0 minus 9 is minus 9. So that's what we get if we square the numbers and subtract them. What do we get if we add the numbers and times by 3? Well, let's add the numbers first and then multiply by 3. N plus n minus 3 is 2n minus 3, and we want to times all that by 3, and we get 6n minus 9. We've got the same answer for general numbers n and n minus 3. We get 6n minus 9 both times, so that shows us that this result is true algebraically. Thank you very much for listening to the video. I hope that helped you in your revision for your Unit 2 exams.